video, we are going to look at how to calculate the oxidation state of a compound, case 1. Alright, before I proceed with teaching, I would like to quickly inform you guys that Smart Learn Academy is holding a free tutorial for Jambites, both art students and science students. So all you need to do is just to go to the comment section. You will see the link below. Just click on it. That will lead you to my WhatsApp group. Alright, now let's continue. How to calculate the oxidation state of a compound, case 1. Now, to calculate the oxidation state of a compound is very simple. Now, these are the following rules that you are meant to take note of, and it's very simple. This is the case 1 aspect of it. Now, the first rule says, first check if the compound is charged or not. What do I mean by if the compound is charged or not? That is, if the compound is bearing anything positive or negative up. Look at what I mean. For example, let me say that you have something like this. I'm just giving you an instance. That doesn't mean that we have such a compound. Just look at these two guys now. Now look at this is CO3, this one is CO2 minus. Now this one is charged because of the presence of minus 1 that is here. Now look at this one. This one is not bearing anything plus or negative upward. So that's what I mean by check if the compound is charged or not. Alright, rule number 2 says if it's charged, equate to its charge, but if the compound is not charged, equate it to what? 0. Alright, now the third rule says always remember that oxidation state of oxygen is -2. This is the oxidation state of oxygen, is always constant, and that is -2. Alright, the fourth rule says that the oxidation state of elements in group 1 is 1. Why those ones that are in group 2 is 2. Alright, let's quickly solve 1 or 2 examples as regards to under this case 1. For example, let's assume that you were asked to calculate the oxidation state of carbon in this particular compound, let's say CO2. For example, so and you're looking for the oxidation state of carbon, which is C. Now, the first thing you will check is whether this young man is charged or not. Now, looking at this, if you look up over here, there is nothing like minus or positive sign. So it simply means that carbon 4 oxide, it simply means that this compound is not what? Charged. Now, according to our rule, we say that if it is not charged, you will equate it to 0. So I will say equal to what? 0. Now, what you will do? Now, since we are looking for the oxidation state of carbon, now you will write what? C, because that is the one you are looking for. Now, this is oxygen, right? Now, always remember that the oxidation state of oxygen is what? -2. So what you will do is that you will ask yourself, in this compound, how many molecules of oxygen do we have here? And we have 2 molecules of what? Oxygen. So what we now do is that these 2 will multiply the oxidation state of oxygen, which is -2. Remember, this -2 is always what? Constant. So since you have 2 molecules of oxygen, these 2 will multiply it by what? Oxidation state of oxygen, which is -2. So you are going to have 2 times -2 will give you what? -4. So you will have C -4 to be equal to what? 0. So what we now do is that we will now make C subject of the what? Formula. And when -4 crosses the equal sign, you will now have that C is equal to plus what? 4. So that simply means that the oxidation state of carbon here is what? 4, and that's why we call it carbon 4 oxide. Okay, now let's quickly look at another example. Let's assume that you are asked to find the oxidation state of sulfur in this particular compound. Now look at this. Let's assume you are asked to find the oxidation state of sulfur here. Now remember our rule. You will check if it is charged or not. Now looking at this young man is charged, right? Because you can see minus a particular number here, right? So it simply means that the young guy is what? Is charged. Now, according to our rule, if it is charged, you will equate it to that charge. So since the charge is -2, I will equate this into be equal to -2. Remember, I'm following the rule, right? You are equating to -2 because what we have over here is -2. If it's minus anything plus anything, you will equate it to what? To that. But if it doesn't have anything here, you will equate it to what? 0. Now, what will I do? You are looking for oxidation of sulfur, so I will write S bar. Now look at this now. Now you will come over here. This is oxygen. How many molecules of oxygen is in this particular in this particular compound, that is 4 molecules of oxygen. Now this 4 will always multiply the oxidation state of oxygen, which is always -2, is constant. So when you say 4 times -2 will give us what? Minus what? 8, equal to what? -2. Now what will happen next? The -8 will cross the equal sign, and when that happens, you will have that S becomes equal to -2 plus what? 8, and -2 plus 8 will give you plus what? 6. So what does that imply? It simply means that the oxidation state of sulfur here is plus what? 6. Alright, now let's take it higher. Let's take it higher. Let's assume that we have something like this, Cr2O7 minus 2. For example, okay, now, so let's assume that in this case, you were asked to find the oxidation state of chromate, which is Cr. Cr, that is chromate. Now what will you do? You will first of all check whether the compound is charged or not. Now looking at this young guy is what? Charged. So, and the charge is -2. I will equate it to minus what? -2, right? Now you are looking for the oxidation state of chromate, which is Cr. Now this is Cr, Abi. When you write this Cr, but if you look at this compound, how many chromate do we have here? You can see Cr2, right? So because we have 2 Cr2, so I will write what? 2 here. Now remember, I wrote this I bring out these 2 here simply because we have what? 2 molecules of chromate here. If you see Cr3, you will write what? 3 here. You know, in the other one that we have been doing, just like when we did carbon and that of sulfur, I did not put any number there because that is only 1 sulfur, another one is only 1 carbon. But this time around, you are having 2 chromates, so that's why I'm putting the 2 at the back of this word, Cr. Now what will you do next? You will go to the oxygen aspect. How many molecules of oxygen is here? We have 7 molecules of oxygen, and always remember that the molecule of oxygen that you have will be multiplied by the oxidation state of oxygen, which is always -2. So when you say 7 times -2, that is going to give us -14, equal to -2. Now what are you going to do? We will make Cr subject of the formula. Then -14 will cross the equal sign. We will now have that 2Cr become equal to -2 plus what? 14. Then when we continue, we now have that 2Cr -2 plus 14 is going to give us what? 12. Now we divide both sides by what? By 2. When we do that, we will now have that Cr is equal to what? 6. So what does that mean? It simply means that the oxidation state of chromate here is what? Is 6. So this is how you can be able to calculate the oxidation state of an element in a what? Compound. Remember, this is just case 1, right?